Good morning, everyone. Oh, I just lost my music. That's interesting. Let's get the music going again here. What happened? Well, good morning, everybody. While I work out the details of my music, thanks so much for tuning in. Rob here with another Fusion 360 live stream. Let's see if we can get this music going again here. Where's my music? Where's my music? Let's see. I know what the problem is. Well, no worries. I switched to a full screen view and I don't have the music activated on that channel. So be it. We'll get the music going when we start working. So thanks so much for tuning in. I hope you're all doing well. Hope you're all healthy. Hope your families are healthy. We are going to continue on the journey of Fusion 360 that I've been on over the past few weeks. Had a couple of breakthroughs over the weekend. Sunday was not so nice weather, so I used that as an opportunity to learn some of the things that I've been struggling with. Last time I was working on the piston design. That was kind of a work in progress. I may go into that a little bit halfway through the stream today. But previous to that, we were playing with our lever design, right? Our little linkage lever design, which I'm still just so pleased with how this came out. And I was starting to play with trying to get things to move in Fusion 360 because you can create motion to basically demonstrate how the different pieces will work together. Had no idea how to do that. I was just kind of playing with the settings. And I don't know if you remember from the video, but the pieces were spazzing out all over the place. I clearly had no idea what I was doing. So I did a little research. I found some great resources online that I'd like to share with you all, and I'll talk a little bit about what I learned. Then I'm going to work on a couple of little projects to demonstrate that. Learned some really useful stuff. I found a great YouTube channel that I will show in a moment that really broke it down in a way for me as a non-engineer, trained CAD designer to learn, and it really, really helpful. So we'll go into that in a second. But yeah, I'm very excited about this. I think it's like a whole new level for me with making complex assemblies in CAD. So let's jump over to a screen grab here, and I'll take you through some of these resources I found. So bear with me for just a moment here. All right. Now we should have some music back on. There's our music. Excellent. So when I switched channels in OBS, I didn't have the music turned on this other scene. So be it. A little abrupt introduction. That threw me for a loop, but so be it. So anyways, I am on this Autodesk blog post about components versus bodies for new designers. Now, up until this point, I really had no idea what a component was, how it was used. The only thing that I knew is that components are necessary for creating motion, for demonstrating the motion of a part. So I did a little snooping. I found this post, which we'll go through in a second, but I also found this YouTube channel. This is Lars Christensen, and he is a CAD designer, and he has such fantastic videos about Fusion 360 for beginners into more advanced things. And I found a couple of videos on how to use components to create joints, to create motion. And I probably watched about an hour and a half or 2 hours of tutorials with Lars. And first of all, he's very, very energetic. I really, really like the way he shows all the different features, explains it in a really great way. I just really, really appreciated how well he broke it down for a layperson like me to understand. In addition, he touched on exactly what it was that I was trying to do, which is to get things to move, which opened up this world of using components. So, Lars, thank you very much for the great tutorials. Keep up the great work. We'll throw a link to his channel in the description after I'm done with the stream. So, excuse me. So, components versus bodies. So, this article is great. It's a little bit long, and it breaks down the differences between components and bodies. Now, up until this point, I only modeled with bodies, which is I would create a sketch, and as soon as I extrude that into 3D space, that then becomes a body. And so a body is defined as any continuous 3D shape. Sphere, cube, cone, continuous 3D shape. So I've been modeling with bodies and then sketching on bodies to manipulate them and then using geometry like offsetting planes to attach things to it, which is fine. There's another step to this, which is components. And a component is its own unit that contains its own bodies, sketches, geometry, so on and so forth. So a good way to look at this is there's the author of this article created this hierarchy, this little flow chart here. So the assembly is my entire project. For example, this would be the assembly, the project that this is contained within. Then each important part of this would be its own component. So for example, the base, which houses the little box and then the hinge, that would be its own component. The lid would be its own component. The lever arm would be its own component, and the linkage arms would be their own components. And each component has its own bodies, sketches, and origin points. So it's almost like its own self-contained unit of its own sketches and all the bodies included with that component. So a component could have multiple bodies included with it. The other thing that I learned that's really interesting is that components, let me find this section of this article really quickly. Components, where is it? Well, I can't find it right now, but components have their own timeline on the bottom of the screen. Now, through this whole process, my little banner on the bottom of the screen has covered up my timeline, but in Fusion, you have actually a timeline of all of the actions that you take. Add something, delete something, push, pull, whatever. It keeps a timeline of that so you can jump back and manipulate any of those steps along the way. Well, each component has its own timeline, so that way, if you have a really complex assembly with lots of different components, you don't have this extremely long, complicated timeline. Each component has its own timeline. So if I need to go and manipulate one component in my entire assembly, I don't have to dig through this incredibly long timeline to find that. I think that is an amazingly cool feature. As I'm learning more as well, let's just jump to the top of the article. Lars mentioned this in a video. He did a really, really good job. But in traditional CAD software, like something like SolidWorks, the way that you would make an assembly is you basically have to create each individual part as its own file. So for example, if you're talking about this wrench, the knurl, the pin, the spring, and the jaw would be all their own parts. And then you would have to, what is the file called? You would use a primary assembly. So I guess that's a function in SolidWorks that pulls all the files together to make an assembly. The problem is these are all individually linked files, so if you lose one of the files or it gets moved, the assembly will fall apart. In Fusion, it's all self-contained in this one assembly with all these different components. So I really learned a lot this weekend. I think I'm starting to grasp the way that this is supposed to go. We're going to jump into actually applying this in a couple of minutes. But I learned a lot from Lars. I can't stress enough that Lars' videos are amazing. And I've watched a bunch of Fusion 360 tutorials before. They've all been pretty good, but I think Lars really breaks it down in a way that a layperson can understand, and I really appreciate that. Before we get started, I do have to shout out Wolf and Raven again for the amazing tunes. Once again, I'm playing the Ace of Space record because I love it. I'll throw a link in the description to listen to this record as well as Wolf and Raven's other music. Also, just as an aside, on our YouTube channel, the Digital Arts Experience YouTube channel, I'm a huge music fan, obviously, and one of my amazing instructors, Josh, is a huge music guy, and we are starting a music review podcast that we're going to get out probably this week, if not early next week, the first episode, where we're going to listen to a record, break it down a little bit, talk about our reactions, and if you're a music person like I am, definitely recommend you check that out. Stay tuned. We'll fill you in on that soon. But at any rate, let's jump into using components in an assembly. And I'm going to make a couple of simple projects to talk about how this is going to work. So let's jump over to Fusion. I've got my Fusion project here. Now, what I learned from Lars is when you are making an assembly, like let's say I was going to remake this, which I could probably make really quickly now that I've gotten a little bit more experience, you don't want to draw up all of the parts and then split them into components. I want to take this object and say to myself, the base is going to be its own thing. So I'm going to create a component called base, and we'll model all the base stuff in that. The lid is going to be its own thing, so I'm going to create a component first and then model the lid in that component. The reason for that is if I had created all the bodies and then turned them into components, I would lose the revision history in that timeline. So this requires a little bit of planning, which if you've watched any of my streams, you know that I'm terrible at. But you have to think through this a little bit. it helps to make some sketches so you can kind of think through the design. But basically, you would need to, excuse me, you would need to think about what components are going to be in your assembly and set those components up and name them from the beginning. So I think to start with, I'm just going to make a simple lever mechanism like this, where there'll be a base with the two sides of the hinges and then the centerpiece and the pins. And we will put that together and then use the joint feature to make this move and talk a little bit about the types of movement options there are. Now, I don't know all of them. I'm still very new to this, but we're going to do our best. So we are now in this project. I'm going to save it. We'll just do a quick save, and I'm going to call it... I'm going to make a new project here. I'm going to call this Joints. All right, so this is just going to sync. I've been putting all of my models in one project, and I really should be splitting them up into other projects. Like, I should have had a project called, like, piston mechanism, and then I could put the different versions of that in there. It'd just be a little bit easier. So I don't know if this is going to take all day to sync. Well, at any rate, I'm just going to call this lever. I'm just going to put it in Rob's first project, and I'll fix that later. Oh, come on. What's going on, Fusion? Are we frozen? All right, cool. We're frozen. Let's try this again. Lever. All right, great. So we're all set. So before I get started doing anything, this top level is my assembly. That could be viewed as a component because, first of all, this cube icon indicates a component. This little radio dial here indicates that it's active. So if I wasn't using any other components, the assembly itself, this top level item, you can think of as a component because it contains bodies and sketches. We are going to create some additional components. So what I'm going to do is right click and I'm going to say new component. And this one we're going to call, let's just rename it. I think I could just double click base. Okay. Now, see how it says base with the little colon and the number 1? If I was to duplicate this, it would say base 2. The other thing, and I might be wrong about this, and if you know, throw a comment in. I'm going to check with Lars to see if this is right or wrong. If I was to model a base and then duplicate it and manipulate one of them, it would manipulate both of them. I think they're connected. If we jump back to this blog, I think it says, if we go to the changes to copied component can affect the original component. So whereas when you copy and paste a body, if I made a cube and copied and pasted it, it wouldn't change if I changed one of them. The original wouldn't change if I changed the new one. I don't think that works with components, but I'm not sure. So we're going to have the base. We're going to so now you'll notice my top lever component now is an assembly. See how it's got the set of cubes put together? It's no longer a single cube. So that indicates that we now have an assembly. So I'm going to go ahead and we're going to create a new component. I'm going to call this lever. And I think the final component we're going to use is we'll make a component of the pins that are going to go into the lever to have the hinge function properly. So we'll create a new component and we'll call this pins. Okay, great. So now I have 3 components. If I open these up, right now all I have is an origin, but as I start to model this, we'll see that this is going to come together. So the other thing as well is we'll start to see, not that you'll see it because my banner's covering it up, but each is going to have its own timeline. What I could do actually, hold on a second. Let's see if I shrink this a little bit and see if you can see. Ah, there we go. Okay, good. So that's a bit better. Now you can see, almost see my timeline. Let's bring that up just a touch more. There we go. So you should see my timeline now. That's not something I've had in the past. So anyway, okay, so let's make the base. So we're going to create a sketch. And I want to open this just so it opens up. And I'm just going to make a square base. We'll make it, 50 by 50. Right? And I think we'll round off the corners. Actually, you know what? Let's just keep it really simple. So 50 by 50. So that means what we're going to do now is let's press pull this. And it's going to be... Oh, I just realized I'm modeling this in the pins component. So let's undo this. See how the little radio dial is selected here? I need to select this, so I'm working in the base component. Rookie mistake. But I can get away with that because I am a rookie. So let's go ahead and model our 50 by 50 millimeter here. All right, 50 millimeter by 50 millimeter square. Press pull. I'm just going to make this 5 millimeters. Great. So now what we're going to do is we're going to make the hinges. So let's, the little round parts for the hinges. I'm not going to make this pretty by any means. It's going to be very simple and straightforward. So what we'll do is we will sketch. Take a look at my base component, by the way. I now have origins, which are my XYZ axes. I have a body now created, and I have sketches. And these are self-contained in this component, which is cool. Now, quickly, if I switch to another component, my timeline changed because this lever has its own unique timeline. Very cool stuff. So let's make the center point circle. I don't know. I have no idea. I'll make it 50. That's too high. It's too high up. Let's bring it down to here. That'll work. That's a little close. Whatever. It's all right, let's do it this way. So look at our center point. Nope. One more time. Come to here. There we go. That'll work. Perfect. So there's that. Nothing fancy here. We're keeping it simple today. Okay, great. So we've got that. There's our sketch. We're going to bring that in -10. I'll do 10 and 10. And that would leave me 15 in the... no, that's not true. That would leave me 30 in the middle. So I can bring it in 15, 15. And that would leave me 20. We'll do 15, 15, and then 30 in the middle. All right, that's fine. All right, let's do the same sketch on the other side. Okay, so we should be able to find the center point of this circle. There's our 50, very good. Use the other side as a guide. Works pretty nicely to model this way. I'm sure there's another way to do this, but this seems to be working well for me. And so now we can pull this in. -15. Great. Yeah, no, I'm gonna keep it -10. That was a mistake. Okay, very good. All right, so there's our base. The only thing I have to do now is just make the center hole for the pins that are going to hold the lever in place to work. So let's do that, and then we can call this base completed. And then what's nice is I can just completely hide this this component if I need. So let's carry on here. If you have any thoughts or you want to see me make anything in particular, throw a comment. I'd love to learn. So let's make this, we'll make the pin, let's make it 20. Doesn't need to be massive. All right, so now, lastly, we're going to push that through. All right, so now we've got this base for this lever. Very good. This is great. So I'm going to leave this on while I model the lever component because... actually, I don't need to, but I'm going to do it anyway. So what we're going to need to do now is make sure we save this and now switch to the lever component. So I'm drawing in the right. So what's cool about that is when I deactivate a component, it becomes transparent, which I really like. So it knows that I'm not, I can use this for reference. I can use all the geometry here for reference, but I'm not sketching anything here, which is cool. So I'm just going to model it on the floor over here. So we're just going to go next to it. Wait, what am I looking at here? Let's go to the top. There we are. Okay. So we'll model the lever just off to the side here. So basically, I want to make a 50 millimeter circle. All right. And then we're going to basically push-pull that. So I had a width of 50 here, and this is 10 and 10. So that leaves me with 30. So let's make this 29. So we're leaving a half a millimeter of... Oh, you know what? I have to make the lever first. No. We'll do it this way. I'm going to leave a half a millimeter of tolerance on each side. So let's pull this 29. There's my little circular base. Very good. And now what I'm going to do is actually shut this body off for a moment and put the sketch back on. And what we're going to do to create this lever is we're going to make another sketch here. And let's just flip this. Okay, cool. All right, very good. So now let's grab our line tool. I'm going to have it come up nice and tall. We're going to have this come to about... bring it to about here. All right, there we got that. And then we're going to get our 3-point arc tool. Let's see if we can make a nice arc between here and here. Yeah, I like that. We're going to go with that. Where did I come to? Oh, I just realized this lever's not centered. Let's take a step back. Oops. Try this again. So we're going to basically do this to, let's call it here. Okay, great. Awesome. Now we can do our 3-point arc. I learned another really cool trick I'll show you in a moment. And we're going to come to there. And we'll do the same thing here. Here. Come to there. Great. And then I guess I need to connect these to make it closed geometry, or maybe I have to connect these. There we go. Now it's closed geometry. All right, very good. So now we're going to basically press pull this up, our 29, right? And then basically we're going to press pull this up. Let's bring it up. Let's see. So it would be, let's bring it up 20. And I don't want to cut. I want to join. 20. So 29. 14 and a half. 29 minus 14 and a half is 29. I should be able to do this in my head. Is 14 and a half. Right, that makes sense. Stupid. All right, so 14 and a half. So 7.25. So it's a 29. Put this up. I don't know why I'm having a hard time centering this. I don't know. I'm being stupid right now. Hold on a second. Let me just grab a calculator and let me figure this out. So, all right. So then we need to do. All right. So this needs to be 21.75. And then basically what I can do is now I should be able to grab this. Oh, I'm so stupid. I don't know why I can't figure this out right now. Huh. I'm having a hard time with this. This is something I should be able to do nicely. Also, I messed something up, so let's take a step back. Oh, I totally messed something up in this arc. Okay. Let's try this again here. All right, so I know what I'm going to do. I know what I'm going to do here. So let's just fix the 3-point arc, and then I'll figure out what I'm doing. 3-point arc. What is going on right now? Hold on a minute. All right. Let's try this again. I don't know. I don't know. I'm being stupid today. All right. Yeah. Okay. Let's just Actually, you know what we're going to do? I have an idea. We're going to make this easy. Press pull. We are going to make this 29 because I have 30 as a space in there. Okay, now what I'm going to do is I'm going to... Oh, I can get rid of this too. I don't need this. What I'm going to do is I'm going to create an offset plane, and I'm going to bring that down negative 14.5, so that's dead center. And now I can sketch on this offset plane to make sure that my handle is in the right position. So, all right, that was like a little brain fart, but that's okay. All right, cool. And now let's just get that 3-point arc. Nope, messed that up. 3-point arc. Okay. That's fine. Cool. Good enough. All right, and I think I probably need to connect this here to make it a complete... There we go. So now we have geometry. Okay, so now I can basically press pull these guys. And I'm going to bring it 7.25 up. And it's not cutting. It is joining. All right, there we are. And then I'm just going to do the same on this side. So I'll basically extrude this downward 7.25. There we are. Okay, very good. So that was very silly, but so be it. All right, and then I think we made the diameter of that 20. So let's go ahead and sketch on top of this. Hold on. Here, sketch. We'll make our center point circle and push that through. So 20. All right. And now we can press pull that, and we're just going to bring that through. All right, there we go. Lever, not pretty, but it'll work. Okay, awesome. So I think that's done. Let's model our pins, and then we can assemble this all together. And then we're going to add our motion. So let's see what shakes out. Leave that there. Okay, very good. So we are done with this lever. That means that we can bring our next active component is our pins. Okay, and so the pins, I think I'm going to model them... I think I'm going to model them right in the side. Somebody's calling me right now. Let me... that's fine. No problem. Okay. So we are modeling on the side of this other component, but creating the sketches in the pin component. So I'm actually going to just create an offset of 0.5 because I want some tolerance. And now I can sketch up against this, which is awesome. So... what we're going to do is, let's see if I can find the center point of this. So there's, that should be the center point. And we're going to do 19 millimeters. That looks good. Okay. And first thing we're going to do is press pull this straight through. And it's going to be 50. Oh, negative 50. 51. All right, let's try that. Okay, very good. Okay, so that's going through fine. Then what we'll do is model. Now we're going to do a sketch on this face, and then we're going to make the size of this. Let's make it 30. Very good. And then we can basically pull this out 5. And then we can, of course, fill at the edge. So what's nice about this is I'm creating this pin actually in the right place in my model without having the bodies fused together because I'm doing this all with separate components. The truth is I could have modeled my lever in the right place to start out with and there wouldn't have been a problem, right? It's just such a better way of doing things. I'm really pleased. So let's go ahead and put a 10 millimeter spot in here. That I'm going to press pull in negative 10. Cool. All right. And then what I'm going to do is actually create another offset plane by 0.5. Right. So we have some tolerance here, and that will make sure things aren't fused together. And we'll sketch on this. And what we're going to do is sketch a 9mm piece. Okay, and that is going to be press pulled -10. And now we can sketch on this face. Once again, 30. And we can select this and this. Press pull. And that we can bring out 5. And then, of course, we'll fill at our edge. And we're going in 3. The other thing I learned about Fusion from Lars is I learned that... hold on one sec. I learned that... I just have to see who's calling me here. Somebody's bugging me. I don't know who this is. Oops. Dropping stuff all over the place. Okay. I learned that when you're extruding things and cutting things, only things that are visible will get affected. So, for example, if I was cutting a section out of something else and there was another part kind of intersecting in the way, if I hid that part, it wouldn't cut that, which is really cool. It only affects things that are visible. So, all of our components are set up. So, let's go ahead and select this. We can see we have, when we select our top level assembly, everything becomes visible. So, what I'm going to do now is we need to start creating some joints. And there's something I learned from the videos that I watched with Lars that indicated some necessary steps, which is why I was running into problems before. Okay. Let's see. Okay, so what we're going to do to set this up, first thing is I'm going to shut the pins off because I don't need to see them. The first thing that you have to do is you have to ground the base. So there's going to be a rigid component that's not going to move, and you have to ground that as the base, and that's obviously going to be our base piece. And to do that, I'm going to right-click, and I'm going to ground this. So this is now the basis in which movement happens, okay, which is great. Now, the next thing we're going to do is I don't want these pins to ever move. So what I'm going to do is I'm going to select... Oh, no, that's not right. I'm going to select both of these together, and we're going to create a rigid group so that these... It locks the relative position of the selected components. Now, there's no potential for my joints to move in this, but let's say that this hinge mechanism was also a moving item. Well, we want the pins and the base to move together, so we're going to create a rigid group out of those. And when you create that rigid group, now that these items will move together. Now, obviously, the base is never going to move, but I could connect two items together so they move as a unit, even though they're separate components. It's almost like grouping them together. So now we've got our rigid group, we've got our base set, and you'll notice there's a little thumbtack in the icon next to the base component that lets us know that that's grounded. So I'm just going to shut the pins off. Now, I need to specify where my joints are going to be happening. And if you remember, I left some tolerance. I left a 0.5 millimeter of tolerance on either side with this lever mechanism. So quickly, I want to just show you how to create the lever. Then I'm going to undo it, and we're gonna do this the proper way, which is, so to create the movement, I need to create a joint. So what I'm going to do is I'm going to create a joint, okay? And the joint is going to be, we're going to start with this component. Now, the way you want to do the order of operations with the joint is you want to select the piece that is going to be the moving one first, then select the base. So the pivot point for our joint is going to be this spot here. And you can see this little, like, black and white cookie. That looks like a little black and white cookie or a half moon. Lars described it as a half moon. I can attach that to like anywhere on the geometry of this shape, right? And that means I can basically joint any of that. I want it to be this center point here. So I select that. Then I come over to my base and I select the middle part of this ring here. And now my shape comes over here and it starts spazzing out, right? So if you notice, it's off center because when you joint something, they're slapped together. Now, we've modeled this with tolerance. I could have modeled this without tolerance, but obviously it wouldn't have 3D printed well. So that's not going to work because I have the joint and then the joint, and that's not going to work very well. So I'm actually going to cancel that. And what I'm going to do on this object is I'm going to select the base and I'm going to create a joint origin, okay? So my joint origin is going to be the center point of this, and then I'm going to offset it by 0.5 millimeters, right? So that way the joint origin is actually offset from the side of this, and that way the lever isn't rubbed up against it. It's going to be dead center the way we want it to be. So now I should be able to come over here and I can go to Assemble, Joint, and I can grab this point right here, and then I can grab my origin point that I created, and you can actually see it's offset, and I'm going to slide that over. Now, again, this spazzes out really weird. So now that we've got set, this isn't... Oh, I must have selected the wrong point. Let me do that one more time. Because I had made... This is a width of 30, and we made that 29. Okay. Let me make sure that I had... let me undo this, that origin point. I may have done that incorrectly. So let's do that again. So assemble, joint origin. It's going to be here. And then we're going to move it negative 0.5. I went the wrong direction. And then we'll do this again. I went the wrong direction, so it was 0.5 millimeters the wrong way. So we are going to create a joint. I'm going to grab this. I'm going to grab my origin. Now, yeah, there we go. Now our tolerances look right. Very good. Okay, so now we need to select motion. And right now it's on rigid, which is not what we want. We want a revolute motion. And there we go. Now this is spinning. Okay, so we're rotating the correct way. I can actually animate that again, right? And obviously it's rotating too much, which is fine. We can set some boundaries later. We also have sliding motion. That's going to slide in a certain axis. Cylindrical motion, right, which is sliding and rotates. Let's see. Or maybe it's, what did that say? Maybe cylindrical. Let's see what it says. Hover over. Component rotates around and moves along a single axis. Okay, this pin slot, which is rotates around an axis and moves along a different axis. Planar, component moves along two axes and rotates around a single axis. And then ball, which is like a bearing, right? Like a gimbal system. So we want to revolute. There we are. Looking good, looking good. And we can hit OK, right? So looking good so far. Now, at this point, I can grab this and I can move it at will, which is pretty cool. What I need to do now is I need to set boundaries because we don't want this to rotate all the way down. We want to set a minimum and maximum, okay? And the way that we can do that is by coming over to our lever, right-clicking on it, and we can set... Oh, I'm sorry about that. We want to go to our joint section. When we create a joint, we get a new section here in our assembly called joints. So we're going to come over here to this. We have our rigid group we had created. That's stored in here. And then we also have this joint. And we can right-click on that and say Edit Joint Limits, okay? So our minimum is going to be, let's call it 90. Nope, 45. Let's see. Oh, I guess 0. Let's see. Okay, so that's 0. So our minimum 0, and our maximum is going to be 90. Nope. All right. 180. There we are. So minimum is going to be 0. Max is going to be 180. And that should be it. So now I should... Well, I went the wrong way. So I have to edit that and flip it. So edit joint limits. We need to flip it. And now it should be the right movement. And you can see I'm now restricted from going beyond those boundaries, which is pretty cool. So that's how joints work. So what I had done incorrectly in the past is, one, I didn't set the components beforehand, so I probably had things mixed up in the wrong way. The other thing is I didn't ground the base of whatever object I was working with. And lastly, I didn't probably assemble the joints the right way with those joint origins, which is pretty cool. So now we've got a nice working hinge. Now, the other thing that's really cool, now I don't have anything in this particular model that's going to demonstrate this, but if we go to assemble, I can actually create motion links. So that means the motion of one joint will drive the motion of another joint. I I don't think I have time to demonstrate that, but you know what? Let's put our pins back on so this looks right. So there we go. Very cool. So, let's do something here. Yeah, this doesn't really demonstrate that very much. So I think we can call this done, and now we're going to switch to another project. So we were going to, I have about 20 minutes left, so we might as well get started on another project. By the way, just to quickly point out, my assembly, I get the full history of the assembly history here, right, of all the different things. That's making this, making this, making this. So the history of that component is stored within, and then I have some stuff that I did globally. Although this might be the entire timeline of everything for the assembly. Whereas if I go into this, I have a much shorter timeline because its timeline is affected only by what's in there. So let's go ahead and create a new project. And I'm going to save this very quickly. And I'm going to call this piston. I think we're going to start the piston mechanism over again. And again, we're going to create all the components separately. So we're going to create a new component, and we're going to call this the base. That's what I'm going to start with. Then we'll create a component. We'll call the new component the crank. We will have... let's start with those two, and then we'll figure out the other components and how they're going to work together. I have to think about that because there's going to be a linkage. That's going to be its own component. All right, so let's do a component from that. That'll be a linkage. There'll probably be some pins that we can do in their own component. There'll be a piston. And that should be it. Well, at least to start with. I'll have to make the pins and everything. So let's get the base set up. We could probably do this much quicker now because I have figured out the error of my ways in the past. So it's going to be 50 by 200. Fine. And then, of course, we're going to put our nice rounded edges like we always do. I did that wrong, as I always do. I want to use a 2-point circle in that case, but I really am using a center point circle, and that doesn't work properly. Okay, so now this, and this can get press-pulled, and we're going to set that up 10. Nope, too much. 5, good enough. Okay, great. So what we're going to do now, that's our base, and what we need to do now is have the little piece coming up for the crank to go through. So we'll sketch on top of this. And let's make this... That should work. Okay. And I think I want the flywheel to be 50, so I think we're going to make this 60. Great. Nothing fancy. I'm not even going to round this off. I really should, but I'm not going to. And then what we'll do is sketch on this, and we're going to make a... Let's see. I think well, you know what? I think before I put the hole through it, we'll do it this way. Sketch. I'm a little confused for a second here. So we need to come up. That was 60. I need the diameter of this to be 50, so let's put it here. That should work. And truth be told... Alright, so we'll make this 20. And I'm actually going to press pull this down. I don't need this to be so high. Okay, great. So that's fine. Okay. All right, so that's fine with the base for now. I'm actually going to come back and edit this. So now let's go to the crank. And of course, our geometry stays active, and I can, of course, sketch on this, which is awesome. So we'll select this face. We're going to offset by 0.5. And now I can sketch on this face. And I can use the center point of this circle here. Should be pretty easy to find, right? That's the center point of that. I'm going to make a 50 millimeter circle, right? And then I'm going to make this circle, I think... I don't need it to be very big. Ah, you know what? I messed this up. All right, hold on a second. I have to go back. All right, let's go back. All right. I'm going to model that right on the edge here. Okay. All right. Cool. So that's 20. All right. Easy fix. Easy fix. All right. That's done. Okay, so that's good. Let's go to our crank. And let's do the same thing we just did. Offset plane, 0.5. We can sketch on this now. And basically what we're going to do is grab our center point circle here. We're going to make our flywheel 50. And then we should be able to press pull that out. 15. Let's make it 10. Okay. And of course, we need to put a hole through it. And then, of course, we'll need our little pin mechanism, but that's fine. So 20. That should be correct. All right, there we are. All right, that's pretty big, but it's fine. And actually, I think I'm going to adjust this base in a moment. It's fine. It's going to be easy enough to do. Yeah, it should be fine. It should be fine. Okay. So the next thing I'm going to need is going to be an identical wheel. So what I'm going to do is I'm actually going to go into this and grab this body, and I'm going to move it and just create a copy and move it. I think that's... That should be 21. There we go. Cool. And then what we'll do on... We'll put a little handle on this, and that should be that. Now, because this is going to be a moving part, I think I'm going to make the pins for this a different component. But before we do that, I actually want to go back and edit something in the base. What I'd like to do is actually push these in a bit. Uh, 10, and I'll do the same on the other side. Cool. Okay. Okay, so that's good. All right, so now let's make a new component. How are we doing on time here? We're going to call this component crank pins. Okay, and essentially what we're going to do is something very similarly. I'm going to get rid of the base for a minute here. Awesome. I'm going to use these other components as the basis of the sketch. This is like so much easier than the way I was doing things before. I mean, this is such a game changer. So we're going to offset the plane 0.5, right? And we're going to sketch on this face. I'm going to create a 19 millimeter circle at the center point here. I'm going to press pull that through. That's going to come through to here. So I think it's got to be 32. 31 and a half, I think, is my... I think that's... No, that's totally flush, so it's negative 32. All right, great. All right, so then on this side, we're going to, of course, sketch... Nope, we don't want to extrude that. I want to sketch here. I want to circle. We'll make it 30. I'm only going to press pull this out, I think about 3 millimeters. I don't need much. And of course, we'll fill at the edge. As usual. Great. So that's the pin there. And then we'll do the same on this side. We'll sketch here. And this will be 10. And we'll press pull that in negative 10. Great. Then I'm going to offset a plane, 0.5. This is so great. This is so great. What a difference. Sketch on my new plane. We will make a 9 millimeter. Nope, not that. That's going to be press pulled in negative 10. And then we can sketch here. We can make a circle. This will be 30. And this will be press pull 3. And of course we'll fill at the edge. Did this the wrong way. Should have done this a different way. It's okay. It doesn't really matter for now. I'll redo it. All right, great. So now that component. All right, so that's good. I'm just going to have to put the crank offset enough that it clears this pin. What I should have done, actually, I can go back and fix that. Let's edit the pins. Let's get, nope, that's the piston. We're going to edit these. Let's go to these bodies. All right, I'm actually gonna shut this off, and then this I'm actually gonna move. Okay, and then what we're gonna do is we're gonna edit the crank, and what I'm going to do here is I am gonna fill this in. So check this out. I have an idea of how we can fix this. So 20. And then basically I'm going to press pull this. Right, so this is now solid. Right? Then I'm going to sketch on this side. And I'm going to make a circle that's 19 millimeters. And I'm going to press pull this all the way through. And it should be, I think, 32 we said. Oh, negative 32. And we are joining. All right. Right, so now that wheel itself is part of the pin. Right? And then this we can sketch on here and make our 10 millimeter hole. Get this out of the way for now. Oh my god. Learning about these components just completely changed the way this is going. Negative 10. Great. Okay, that's awesome. And now I can go to my crank pin. And I should be able to do some aligning. Now this, I'm actually going to delete this body. That's not helpful anymore. This body I'm going to delete too. Not helpful anymore. There we go. And so now, let's see if I can use the align tool between, oh my god, I can, between two different components. Awesome. So we're going to grab this, and we're going to grab this, and flip. There it is. Okay. And then I can select this body, and I can move it in. Ah, beautiful. Beautiful, beautiful, beautiful. Okay, awesome. So save this. How are we doing on time here? Almost out of time. That's okay. So, Much better. Okay, great. So now my linkage on the piston can not have a problem. So let's just quickly sketch. We're going to do this on the crank. On this body, we're going to just sketch some components that have been used. Capture position. Okay, fine. All right, and then I'm not doing anything fancy. This is like the hand crank. I'm not doing anything fancy with this. It's just going to be great. Hand crank. So ideally now, what happened to my pin? Oh, I haven't. It's not selected. All right. So now I should be able to twist this, right? This should move nice and freely. And I can set all that motion up. I'm not going to do that until my design is completely modeled. Okay. Now, I need to also edit this and make a hole in it so I can fit a pin. You know, I think I need to edit this and pull this in. Let's bring this -3. Nope. Let's see if I can use extrude and not press pull. Yeah, so that's moving everything. And I don't want that to happen. All right, we'll just deal with it. It's fine. It's fine. We'll be okay. Okay. Yeah, I probably made some errors in this again, but it's fine. I just wanted to get started and show how simple it is to model these things while we're using components versus my old way of doing things. Okay. I think we're going to call it from here. I don't think it makes sense to go into such a tremendous amount of detail when I only have a couple of minutes left. So let's save this and let's wrap up here. So as you can see, the use of components is such a game changer when making complex assemblies. Before, I was like having to draw shapes for reference and do a lot of offsetting of planes to draw things the right ways. Now I can create everything as separate components and use all of their geometry, those components' geometry, to model other things without the bodies being connected and getting fit together and all that, which is amazing. Also, you know, from the lever mechanism, we can obviously create very nice motion. I'm really looking forward to the next model. I can show you how we can create linked motion where one thing rotates and it causes something else to rotate or slide. That's going to be really cool. So the idea with the piston mechanism is we can turn the hand crank into software and the whole mechanism should work properly. That's the hope. Don't know if that's going to completely come to fruition, but I'm going to work on it. But thanks so much for tuning in. I really appreciate it. I hope you all learned something. This has been a very exciting moment for me to really take the next step in modeling with Fusion 360. So thanks for hanging out with me while I feel my way through this. Really would appreciate it if you'd hit the subscribe button if you like these videos. You know, we release these, we do these live streams every weekday at 10 and 2. I put out tech tips every weekday at noon. We have lots of really cool content outside of that. If you like 3D modeling, definitely check out some of Nick's videos because he does a lot of really cool stuff with Blender. And check out the DAE.com for our list of online workshops and private lessons if you'd like to take a private lesson in Fusion and get started doing some CAD modeling. Definitely go to the website and send an email, and we'll help you out with that. And I really appreciate it. Thanks so much. Thanks so much for tuning in, and I'm looking forward to seeing you in the next stream.